So hi everyone, I'm Jay and today we are going to see the 8259A. What is 8259A? It is a programmable interrupt controller. You can see that it is a pin diagram of the 8259A. Now let's discuss the features of 8259A. Before going to see the features, if you remember for the 8085 there are total 5 interrupts and the priority of this interrupt is fixed. And some of those interrupts are level trigger, some of those interrupts are edge trigger. Some interrupts are maskable, some interrupts are non-maskable. Some interrupts are vectored and some interrupts are non-vectored. So what I'm trying to say is in the 8085, the first thing is that the interrupts are very few and all the priorities and all the things is fixed. You cannot make any change to that. So if you want to use more number of interrupt and if you want to set the priority of different interrupt, if you want to set that one particular interrupt should be in the level trigger, one should be edge trigger, one particular interrupt should be mask, one should be unmasked, you can also set the priority of the interrupt. So all these things can be done using the 8259A. All you need to do is to interface the 8259A with the 8085. Let's see the features of 8259A. So in the 8259A, all the interrupts can be either masked or unmasked. You can set priority of these all interrupts. You can set whether particular interrupt can be work in level trigger or edge trigger. And total 64 interrupts are possible. So it is a very good thing, right? We are having more number of interrupt and we are having the flexibility, which was not possible in the case of 8085. Let's see the block diagram of 8259. The first block is the data bus buffer. The data bus buffer is connected to the microprocessor using the data bus, which is D0 to D7. So when microprocessor sends any data, it will be received by the 8259A using the data bus buffer, and when microprocessor is receiving any data, it will be received via the same data bus buffer. The next block is read-write logic. Using the read-write logic, processor can send different control signal, using which microprocessor can either read or write data from the 8259A. The first pin is the read bar, which is sent by the microprocessor. So when microprocessor send the read control signal, the data will be transferred from this chip to the microprocessor. When processor send the write control signal, the data will be transferred from the microprocessor to this chip. Then there is a A0, which is the first line of the address bus of the microprocessor, and there is a chip select. What is a chip select? Chip select means if you want to communicate with this chip, the pre-requirement is to send signal at this chip select pin. The next block is cascade buffer comparator. Now, what is the meaning of this block? There is a possibility that you can connect multiple 8259A with the microprocessor. And when you connect multiple 8259A with the microprocessor, in that case, using this block, you can select one 8259A chip from many chips that is connected to the microprocessor. For the cascade buffer, there are different pins such as CAS0, CAS1 and CAS2. Means cascade 0, cascade 1 and cascade 2. The possibility of this 3 pin is from 000 to 111. The range that is possible for these pins is 000 to 111. So total 8 chip can be connected with the microprocessor. Then there is a enable. The next block is the control logic. You can see that in the control logic there are 2 pins. The first one is the INT, means the interrupt, and the second one is the INTA bar, means interrupt acknowledgement. The INT pin is originated from the 8259A and it will be connected to the interrupt pin of the microprocessor 8085. And if you remember, the processor is having output pin which is INTA bar, interrupt acknowledgement. So the output pin from the microprocessor INTA bar will be connected here to the control logic of this 8259A. The next block is the interrupt request register. So when the interrupt is received, In this register, the interrupt will be saved. The next one is the priority resolver. So you can set the priority for all the interrupts. You can see that in the 8259A there are total 8 interrupts possible, that is IR0 to IR7. So you can program the 8259A and you can decide that which interrupt is having higher priority and which interrupt is having the lowest priority. So all these things are programmable and you can set whatever you want to do. The next block is the interrupt service register. So the interrupt which is having highest priority in the priority resolver will be transferred to the interrupt service register. And after that, the next register is the interrupt mask register. Again, like I just said, that these all interrupts are programmable. You can mask some interrupts and you can unmask some interrupts. So when you mask interrupts, the value for the mask interrupt will be stored in this register. So from this block, the 8259A can decide that which interrupt are masked and which interrupt are not masked. Now let's see the working of the 8259A. Right now, from the 8 available interrupts, IR0 to IR7, 3 interrupts are arriving at the 8259A, which are IR0, IR1 and IR2. When the interrupt arrives, the function of the interrupt request register is to store the interrupt. So whenever the interrupt is arriving, the interrupt request register will store all the interrupts. You can see that the IR0, IR1 and IR2 are stored. After that, this interrupt will be transferred to the priority resolver. Now, this IR0 and IR1 and IR2 are just stored. After that, the 8259A will see the priority of the interrupts. Because we have programmed the 8259A, we have decided that the which interrupt is having a higher priority and which interrupt is having lower priority. So interrupt priority resolver will arrange this interrupt according to priority and it will be stored in itself. So you can see that in the interrupt priority resolver, the IR2, IR0 and IR1 is stored. It means the IR2 is having highest priority, IR1 is having lower than the IR2 and IR1 is having again lower than IR0. Now the interrupt that is having highest priority in the interrupt priority resolver will be transferred to the interrupt service register. So you can see that now in the interrupt service register, IR2 is transferred. In the interrupt service register, whatever interrupt is present, that will send the interrupt signal to the microprocessor. So IR2 will send the interrupt to the microprocessor using the INT signal. Processor will receive the interrupt, processor will stop its current execution and it will send the acknowledgement. When 8259A receives acknowledgement, it can understand that processor is ready to receive the interrupt. So in that case, the 8259A will send the vector location according to IR2 because each interrupt is having some unique vector location. So when interrupt acknowledgement is received by the 8259A, it will send the vector location to the microprocessor. When microprocessor receives the vector location, it will jump to the vector location and from the vector location, it will execute the interrupt service routine. After the execution of the interrupt service routine is done, it will start executing from where it has stopped the current execution. So this is how the 8259A works. Now you can see that in the interrupt priority resolver, the next interrupt is IR0. So again the IR0 will be transferred to the in service register and all the process will repeat. So this is it for the 8259A. If you still have any doubt, you can ask me in the comment section. Thank you so much.